All right, this is AP Physics. We are in Unit 1, and we're doing our Graphical Analysis Motion Lab, and I am doing the second part of the synthesis question, so I'm just going to call it number 1B. And we need to translate our position versus time graph to a velocity one down to an acceleration one. And what I'm going to do is mark the things that I know. And I know the easiest one always, I think, is here. And when I count the lines, that's going to happen at 7 seconds, that the velocity is equal to 0. This slope right here is constant. It's going to change at 5 seconds. So I have a positive slope, which means I'm going to have a positive velocity. I have a constant slope, which is going to translate into a constant velocity. Here, on this side, I have a negative slope, which means I'm going to have a negative velocity. My slope is constant, so I'm going to have a constant velocity. I'm also going to find out the points where things change, and notice here, you can be tricked pretty easy. That is a 14 of when it comes to time at stop, not at 15. And this, I'm going to look down and I'm going to say this happens at 9 seconds, the change, and this one happens at 5. So in this range right here, I'm going to have a change in my velocity because it's not constant. My slope is changing. So I know I'm going to have a negative velocity and I have a positive velocity, so I need to make sure I put an origin line that allows me to have a negative velocity area and a positive velocity area. So, and I know right here, I have to go through my 0 velocity. I have to go through that point. That's going to help me. And I know I'm going to have some transition here and here. So this is going to be my transition. I'm going to have a change. These are going to be constant on both sides. I need to figure out what those constant values are, and I can look. Here's my initial position, and here's my final position, and that's going to have a 5 value. And I can see those on the other side also. So if I go to my equation, my change in velocity is change in time divided by time. My final minus my initial. I went and looked on here that my final is 5 up here, and my initial was 0. So I have 5 meters minus 0 meters. So I'm going to have initial velocity of 1. Here's 0, here's 1. And there is my first velocity. So let's go to this slope. And my initial velocity this time is a positive 5, but my final, it's going to come to a stop. Or it goes back to the origin. I'm sorry. It goes back to the origin. So here's my final, where it came to, where I initially started position-wise. I had 14 seconds minus 9 seconds, my final minus my initial. So I'm going to get a -1 velocity. And these look, the curves look the same, the slopes look the same, so that seems reasonable in my answer. This is a -1. So I draw that across, and now I have to go through my 0 time. This is a nice constant change in slope, so I'm going to be able to join these. Okay, so now we have our velocity versus time. So now I can change that or convert it down to my acceleration versus time. There are some things that I know this graph tells me that will help me down here. This is a constant velocity here because it's a straight line, which is going to translate into no acceleration. Same thing down here, no acceleration. So, and again, I'm going to draw an origin that allows me to have negative acceleration if that's what this problem turns out to be. But I can put some answers in right away. And again, I have here, I'm just translating these changing areas to down here. It's going to help me. No acceleration, so I can put in no acceleration there. I can go over here and put, and really I should stop here, and no acceleration. I should stop at 9. So I need to know what's happening here. I have a negative slope. It's going down like this, so that means I'm going to have a negative acceleration. So let's see if the numbers correspond to that negative slope and helps me prove that I've read that right. Well, I know acceleration is change in velocity of time, so my final minus my initial. So if you look on the graph, we knew we had an initial or a final velocity of -1. We were below the origin, and we started with a positive velocity, but we're subtracting, so I have a negative minus a negative, so I get a -2. That happened over a range of 5 seconds, 10 seconds minus 5. So my acceleration is a negative 0.4 meters per second squared. So if I go to here, and I can kind of, this was a -0, this would be a -0.5, so I'm gonna guess that it's like right here. I want my stuff to be proportional. They want things to be proportional. When they give you values, you need to make sure your graph is proportional to them on the test, so we do it correctly. So again, I could leave my answer with a dash, dash, dash like this, or I can also join them in. It kind of helps me see it. And there, now I now have all 3 graphs.